Right, so we're on to the first applied question in the CWC test, which is a stats question, and we're given that in this region of Pandora 5% of people have blue hair, so 95% don't, and it says in a random sample of size n taken from this region, the number of people we expect to have blue hair is 3. So hopefully you recognise this as a binomial problem. So we've got a sample size of n, we're given the probability there of blue hair, which tells us it's binomial, and the expected value of a binomial distribution is always equal to np, the sample size times the probability, which kind of makes sense, doesn't it? We would expect 5% of the n, so multiplied, to have blue hair. So we know if we substitute in what we're given, the expected value, expected number of people with blue hair is 3, the probability is 5%, so 0.05, and that sets up an equation for us to find n, so n is 60. So one method mark for setting up the equation, and then an accuracy mark there for the answer. Then in part B, a much bigger question, we're asked to do a hypothesis test. So Patrick claims that blue man people have a probability greater than 5%. And it's really important that you look carefully at the wording here. So we're looking at where our test is whether it's greater than 5%, whether P is greater than 0.05. Whenever we do a hypothesis test, the first thing we should do is write down our hypotheses. So the null hypothesis assumes that P equals 0.05. It assumes that kind of nothing has changed. But then we're going to test Patrick's claim, which is that more than 5%, so P being greater than 0.05 being our alternative hypothesis, and you'll get a mark for stating those two correctly. We should also state the distribution, assuming that our null hypothesis is correct. So we're going to assume that P is 0.05, we're given n as 50, and we know it's a binomial distribution. So this is our assumed distribution if the null hypothesis is correct. And then to do the hypothesis test, there's two very different approaches. The first one I'm going to go through is the p-value method. I would suggest the more efficient method, but I would recommend making sure you understand the critical region method perhaps before you start using this one. So for this method, we have to find the probability of getting the test result, which was 4 people with blue hair, or more extreme. So what do I mean by that? Well, 5% of 50 is 2.5. We would expect, if this was true, we would expect 2.5 people to have blue hair, but we got 4 people, so that's more than we would expect. So we would look for the probability of getting the 4 or even more extreme, so more than 4. So x is greater than or equal to 4. So that's the probability we need to find. Our calculator won't work that out, so we have to rewrite it in this form because our calculator will work that out. And at that point, once you've written it in this form, you can get your first method mark there. We can then stick the right hand side into our calculator and excuse me, we eventually get the probability of x being greater than or equal to 4 being that. So that's saying that if our null hypothesis is correct, if this is the distribution, then the probability of getting our test result or more extreme is quite small. But the question is it small enough? So to decide that, we always compare to our significance level. So the significance level 1% is 0.01, and 0.2936 is a lot higher than that. It's definitely not small enough to suggest that this is not the distribution. So therefore, we have to accept that this is could well be correct. We have to reject the null hypothesis, and always give your findings in terms of whether you're rejecting the null hypothesis. So there is no evidence, we would say, or not enough evidence to reject H0. We then always have to make sure we put that in the context of the question, and I would try to use the wording that they've used in the question. So I said there's no evidence that blue man people have a probability greater than 5% of having blue hair. So we'll look at the second method, which starts in exactly the same way. You write down the two hypotheses and the distribution, assuming that this one is correct. But this second method uses critical regions. And to find it, you have to find the value of x where greater than that value, the probability of x being greater than that value is less than our significance level. So you just try different values, really. You could use the binomial tables, or you could get a table up on your calculator. But if you look at probability x being greater than or equal to 7, which we work out using this, we should write that because that's what we can put in our calculator. That comes out to be 0.0118, slightly more than 1%. So we can take the next one up, which we can rewrite in this form. That comes out to be 0.0032. So that is the lowest value of x where the probability comes out to be less than 1%. So this is going to be our critical region. So the critical region we can say is x is greater than or equal to 8. And from that point it's nice and easy because we know that the number of people with blue hair came out to be 4, and that is clearly not in the critical region. And if it's not in the critical region, we would say that there's no evidence to reject the null hypothesis. And again, we have to put that in context, just like we did with the last method. And that's it for that question. Hopefully you understood that. If not, get along to a subject extension to get some more help. Thanks.